Good morning. Today we will start working on test 3, but let me show you first that I post the blank test on our discussion board today, the one on April the 26th. Okay, we will work on fall 20, spring 20, and fall 19 test 3s. For today, we will work on logarithm and the rest of the chapter. And then, oh, by the way, I forgot to say that this Wednesday, April the 28th, there is a chance that I won't be able to lead the discussion. So it may be a day off, but I will let you know in the morning. Something personal happened on that day that I may not be able to. It just happened to conflict with our class time, and I cannot. I have to attend for that one. Okay, so April the 28th, I may need to take a day off. Okay, just for this Wednesday. I will let you know in the morning, like around, let's say 8 o'clock maybe. I will post it on our discussion board. Okay, well, anyway, let's come back here. I will work on spring 19 and then spring 20 and then fall 20. And I will work on anything from chapter 4, which is logarithm and properties of logarithms and solving equations, so on and so forth. Okay, now let's start with number 1 here. Solve log base 5 of 3x minus log base 5 of x squared minus 1 equals to log base 5 or base 5 or 2. What I will do first, notice that I have log here, right? So I will combine these two logs into a single log. Okay, I will combine those two logs into a single log. Difference of logs is log of quotient. Now notice that when you change that difference of logs into log of quotient, there's already a change in domain, right? But we'll check the domain later on once we get the candidates for the solutions. Log equals log means the arguments must be the same. If they have the same base, of course. Right? And then from here we solve as usual. So 0 equals to 2x squared minus 3x minus 2. I can factor it, I believe. 2x times x minus 2, and this must be plus 1. So we get x equals to -1/2 or x equals to 2. Right? Now then you check against the argument. For example, x equals to -1/2. When I plug in here, is it okay? It has to be positive. Now 3 times -1/2 is negative, so I have to cross it out. Okay, this one is not okay. How about when I plug in 2? 3 times 2 is positive. 2 squared is 4 minus 1 is still positive. So that one is okay. That's it. Okay, that's for part A. Part B. Log base 4 of x equals to log base 4 of x plus 2 equals to log base 4 something. Oh, basically the same question with above. Log base 4 of, that sum of logs equals to log of product. Equals to log base 4 of x plus 4. Now log equals log means the arguments must be the same. So x squared plus 2x equals to x plus 4. Set one side equals to 0. I don't think this one is factorable. So yeah, let's use formula. So the discriminant is 1 squared minus 4ac, that's 17. So x12 will be negative b plus minus square root of the discriminant over 2a. So x1 is negative 1 plus square root of 17 over 2. x2 is negative 1 minus square root of 17 over 2. Now you check against the argument. Okay, this guy is positive, right? You can check using your calculator, but you can see that square root of 17 is more than 4. 4 minus 1 is 3 over 2 is approximately 1.5 or more, right? So if I put 1.5 here is positive, 1.5 here is positive, 1.5 here is positive, so that one is okay. This one is okay. On the other hand, this one here, this is approximately 4 or more than 4. So this is negative 4 minus 1 negative 5 divided by 2 is less than negative 5/2. Once you put it here, that's negative already, right? And we don't allow the argument of any log to be negative. So I have to cancel this one. And just cross it out like that. That's good enough. Okay, you cross that one out and then you box the answer that qualifies. Part C. This is exponential equation. 5 times something equals to 9. So 5 times 4 to the x plus 3 equals to 9. Divided by 5 first. 4 to the x plus 3 equals to 9 over 5. And then I think I would change this into log form, base 4. Log base 4 of 9 over 5 equals to x plus 3. Subtract by 3. Equals to x. Now this is the exact solution. Now the approximate solution, then you use calculator, okay? This is plus, let me change the base into base 10. 9 over 5 over log 4. Then I will use my calculator. Let me show you how to do it. So log 9 over 5. Log 9 over 5 close parenthesis divided by log 4. And then subtract by 3. Negative 2.57600. So x equals to negative 2.57600. And make it 5 decimal places. Okay, this one is approximate solution. So you underline this, oops, for the exact solution that I requested. And also underline this one for the approximate solution. Okay, now let me show you alternative way to do this, but this one I need to write it a bit smaller. Let me enlarge this view so that you can see better. Okay. I will do it this way. This is 5 times. Notice that 4 to the x plus 3 is 4 to the x times 4 to the 3. Is it right? Okay. So this is 5 times 4 cubed is 16 times 4 is 64. Okay, so this is 320 times 4 to the x equals to 9. So 4 to the x equals to 9 over 320. Now change it into base 4. So x equals to log base 4 of 9 over 320. So that's the exact solution. Now, if I want to compute that in approximate solution, then that will be log 9 over... I just want to show you that we get the same result. Hold on. Let me see. I have a chat coming in. Is it safer to use? It's up to you, either one. I cannot really tell you which one is safer. Speaking about safer or not, it really depends on how good you are with your foundation, right? Okay, this is log 4, and you will see we should get the same result. Okay. Yeah, if your foundation is weak and or the topics you're not really have the mastery of the topic, then nothing really safe, right? Okay. Now, but the first, when I see this question first time, my tendency is to do it the way I did it in blue color. You know, it just happened that it is doable in the green one. That's for part C. Part D. Now we have a more complicated one. 2 to the x 3x minus 1 equals to 7 to the x plus 5. Now, if you take a look at my notes, we have actually 4 different ways, 4 different bases to work on, and you can choose which base to work on. Let me just do it in base 10 right away. Okay. Yeah, but again, you can use base 2, you can use base 7, you can use base E. Let me use base 10. Log, I apply log to both sides. And in general, it is okay to apply certain function to an equation as long as you are sure that function is 1-to-1. Log function is 1-to-1. So 3x minus 1 log 2 equals to x plus 5 times log 7. Now, and then I need to isolate the x, so let me distribute this. 3x log 2 minus log 2 equals to x log 7 plus 5 log 7. Then I will isolate the terms with x, so I will move these to the left, and I will move these to the right. Okay, so I have 3x log 2 minus x log 7 equals to 5 log 7 plus log 2. Subtraction becomes addition, addition becomes subtraction. So that I can factor my x. Now we did this kind of routine before. And this is 5 log 7 plus log 2. So x is equal to 5 log 7 plus log 2 over 3 log 2 minus log 7. Now that is the exact solution. Now next, we compute using our calculator. Is the view correct? Okay, that's the correct view. Now parentheses 5 log 7. I will close this first parenthesis for that 7. Okay, plus log 2 and close parenthesis for the 2. Now close parenthesis for the numerator. Divided by open parenthesis for the denominator. 3 log 2 close parenthesis for 2 minus log 7 close parenthesis for 7 and then close parenthesis for the denominator. That's 78.05429. 78.05429. That's the approximate solution. Okay, so the solutions are this guy for the exact form and this guy for the approximate form. Okay, that's for number 1 for logarithmic and exponential equations. Number 2 is on trigonometry. Actually, we can do this already, but let me just leave it to either Wednesday or next week, Monday. Okay, in case I don't show up on this Wednesday, then you will see that on Monday. We will do that on Monday. Number 3, express this difference of logs as a single log and simplify. This is difference of logs. So if we have difference of logs put together becomes log, in this case base 2. Difference of log becomes log of quotient, right? Log of quotient x squared plus 3x minus 4 over x squared minus 4 divided by x squared minus 1 over x squared minus 3x plus 2. So under the log condition, we will divide those rational expressions. But to divide rational expression is to multiply by the reciprocal. And you know what to do next. You will factor and simplify as much as possible. So x minus 1 will cancel. X minus 2 will also cancel. Is that all? Yeah, that's all. So this will be log base 2 of, we want that in single log, right? So log base 2 of x plus 4 times x minus 1 over x plus 2 x plus 1. Okay, that's the furthest we can go. That's for number 3. Let's see number 5. You will see this question number 5 all the time in my test, graphing log functions. Log base 3 of x plus 4 minus 2 was the y-intercept. Oh, this one may be a bit harder. Okay, so f0 will be log base 3 of 4 minus 2. Log base 3 of 4 is not a nice number, but a bit more than 1, I believe. Right? A bit more than 1. And then subtract by 2, that will be a bit less than 0. I don't know for sure. I can use calculator later on, but the exact solution for the y-intercept will be 0, comma, log base 3 of 4 minus 2. Just leave it like that. Okay, if I use calculator, log base 3 of 4, that's log 4 divided by, close parenthesis, divided by log 3, and then minus 2. That's negative 0.73814. But I will use the exact solution for the question. Now, how to find the x-intercept? You set the function equals to 0. Move the 2 to the other side. Now you see this is log something equals to something. Now change it into exponential form. 3 squared equals to x plus 4. You see what I mean? Okay, we change it into exponential form. That's 9 minus 4, that's 5. So the x-intercept will be 5, 0. How about the asymptote of the function? So x plus 4 equals to 0 will give us the asymptote. How about the domain? Well, x plus 4 has to be strictly positive. So x is greater than negative 4. The domain will be negative 4 to infinity. How about the range? The range will be all real numbers. Now let's plot this. X-intercept is 5, 0. Let me use red color. Y-intercept is negative 0.7 something, so approximately here. Oops. Okay, vertical asymptote is x equals to negative 4. This is x equals negative 4. But this is not enough though. We need more coordinates. And that implies, in this case, we need coordinates from the 3 important coordinates. Log base 3 has these important coordinates. This is log base 3. Okay, log base 3. The coordinates are 1, 0, 3, 1, 1/3, negative 1. Now then, use this to move accordingly. We will move 4 units to the left and then 2 units down. So this will be the new coordinate for this. This is 4 to the left, 2 units down. Okay, now this guy 4 to the left, 2 units down will be here. This guy 4 to the left, 2 units down. While this guy here 4 to the left, 2 units down. So now we have these 3 important coordinates as new ones. The new position of those 3 important coordinates. Now then I will connect these dots here. And this one will go down to here. Okay, now in your test, make sure you bubble it big enough though. Okay, bubble it big enough. That's the graph of log function. Let's go on. Do we have more? We will do this one for sure sometime next week, either Monday or Wednesday. The graphing of trig functions is actually the last topic of our test 3. Okay, including in this case secant, cosecant thingy. This is something we will learn either tomorrow or Thursday. Okay, and this part here was part of your test 2 actually, right? Okay, let's do it anyway. I don't know if we did it before, but let's just do it anyway. So what is the y-intercept? So y-intercept will be f0, just to remind ourselves, right? Okay, this is 3 to the negative 3 minus 5. That's 1 over 27 minus 5. That's negative 4. 26 over 27, almost negative 5. 0, comma, negative 4, 26 over 27. How about the x-intercepts? 0 equals to 3 to, oh no, this is actually part of test 3. That's right. Well, because for the x-intercept later on, we need to use log. See, this is 3 to the x minus 3 minus 5. 5 equals to 3 to the x minus 3. And then from here, we need to apply log base 3. So x is 3 plus log base 3 of 5. Okay, that's the x-intercept. The x-intercept will be 3 plus log base 3 of 5, 0. Now, but if we do approximation, then log 5 divided by log 3 plus 3, that will be 4 point something. This is 4.46497. So later on, when we approximate this, the position on rectangular coordinate system, there will be 4.46497, 0. Okay, now the asymptote, this is y equals to negative 5. Just look at the constant of that exponential function. How about the domain? The domain of exponential function is all real numbers. How about the range? Yeah, 3 to the x is positive. Right, so 3 to the x minus 3, that's moving to the right 3 units. Now 3 to the x minus 3 minus 5, therefore, must be greater than negative 5. The range will be from negative 5 to infinity. That's an ugly infinity. This is better. Now let's plot it. Now the thing is, we can't really use a coordinate that is not accurate though. So for example, part A, that's y-intercept 0, almost negative 5, right? 0, almost negative 5. But this number is not reliable. This coordinate is not reliable. Just like that approximate 4.5 for the x-intercept, this coordinate is not reliable. Okay, these two coordinates are not really reliable. I put it there for sake of completeness in my graph. Okay, but I rely more on the following. The 3 important coordinates. This is base 3, right? So 0, 1, 1, 3, negative 1, 1/3. Now move these 3 units to the right and then 5 units down. 3 units to the right, 5 units down. 5 units down. So it will be here. Okay. It will be here later on. And then this guy, 3 units to the right, 5 units down will be here. 3 units to the right, 5 units down, it will be here. So we start from these 3 important coordinates, 3 to the x, right? That's our 3 to the x. That's what it looks like. Now then take the 3 important coordinates, move it to the right 3 units and 5 units down. Because that's the transformation for this though. Replacing x by x minus 3, that's 3 units to the right. And subtract by 5, that's 5 units down. Okay, so from this original 3 to the x, you get 3 important coordinates. And move it 3 units to the right, 5 units down. Now we get this graph. 5, 4, actually that's the next one. And I still need to go to the left here. Yeah, that's what it looks like. Okay, let's see further if we have more. Number 11, linear speed, that's 5.1. Number 13, sector area, that's also 5.1. Number 12 here, this is 5.2, which we will learn tomorrow. And that's it for Fall 19, Test 3 for the rest of Chapter 5. Okay, again, on Wednesday, this Wednesday, there's a chance that I need to take a day off. I will let you know in my discussion board on April the 28th discussion board, like around 8 o'clock in the morning, if I will really need to take day off. I need to go to hospital. I need to go to hospital. And this is for me, not for my son. This is for me. What happened was I took the second dose of my Pfizer, and I have side effects that still stay with me even after approximately 1 week. So they told me that I need to go to hospitals. So I make appointment with my family doctor to check my heart. I have sharp pain with my heart. They need to make sure it's not a blood clot. Because you know that in the past, some people die because of the blood clot, but that was for Johnson & Johnson's, right? I myself already have heart problems, so but I was approved to take the vaccine for Pfizer. I don't think that's an issue, but they would like to know more. Okay, that's for Fall 19. Let's move on to Spring 20. For Spring 20, we have this number 1. Spring 20 is the time that we all move to the remote learning. So you see in Fall 19, I gave 5 pages tests, and that's already long actually. I already give them extra space because we have graphing in one of the page, right? So I give them space. Now in Spring 20, it becomes 6 pages. Is it 6 pages? 7 pages. But I hope it doesn't scare you because it's basically because I space it out. I space it out even more. Okay. Now using what we did earlier, can you try to do number 1A and number 1C on your own? We did some review earlier, right? Okay, let me ask you to do number 1A and number 1C. let's say I give you how many minutes? 7 minutes maybe. Okay. For, yeah, both of you, please do that in 7 minutes. So I come back at 10:12. There's a chance 10:12 you are not done yet, but don't worry. Don't worry. Okay. I want to see how you start. Okay, you do it then. So part A, log of sum of log equals to log of product. So this is log base 2 of x times x minus 2 equals to 3. So this is log base 2 of x squared minus 2x equals to 3. Now, what do you do from here? Change it into exponential form, right? This is 2 cubed. That's x squared minus 2x equals to 8. And then we move to one side, that's minus 8, right? And then we factor it, that's x minus 4, x plus 2 equals to 0. So either x equals to 4, and it's okay, because the argument will be positive here, will be positive here. Or x equals to negative 2, but it is not okay for this. Also for this one. So I will cross that out. Okay, so x equals to 4 is okay. X equals to negative 2 is not okay. Now for number part C, this is 4 times 3 to the 2x minus 1 equals to 7 divided by 4. And apply log base 3. I will add 1 and then divide it by 2. Now, this is the exact solution. And if you want to make it into decimal here, happens to be a nice decimal. This is 1.75, right? If it is nice decimal, go ahead, change it into decimal. Now, then I will use my calculator to compute this. Log 7 over 4, close parenthesis, divided by log 3. And then plus 1 divided by 2. That's x equals to 0.75469. That's the approximate solution. Okay. Now this is if I use base 3 though. Some people just go ahead with the natural log or log base 10. You will get the same result. Okay, you will get the same result. Now let's go on with part B and part B and part D. Okay, let me give you, I need you to be strong in this because you know this will be on your page 1 in your test, right? Okay, so let's do this one first. Move the log base 2 to one side. Log base 2 of x squared minus 6x minus log base 2 of 1 minus x equals to 3. So this is log base 2 of x squared minus 6x over 1 minus x equals to 3, and changed into exponential form. Now I want you to go on from there. Okay, I want you to go on from there. And then on the right hand side here, let's use base what? Do you want to make a choice for me? Choose it for me. What base you want me to work on? 2, 3, 10E. for part D? Base 10, okay, so this will be, this is, let me write it down first, 2 to the 4x plus 1 equals to 3 to the x minus 2, apply log base 10. And then move the exponent to the front. Don't forget to use parentheses though. Okay, please, please. That's actually the most common mistake made by those students who actually supposed to be doing well, but because they omit the parentheses, they end up distributing only the 1 instead of the 4x as well. Now I want you to go on from here. Okay, both of these part B and part D, I will give you maybe 6 minutes from now. 10:25. No, 10:27. Yeah, 10:27. Okay, do as much as you can from here. Okay, let's start again. That's equals to 8. So this is x squared minus 6x equals to 8 times 1 minus x. I will distribute the right-hand side. Move to one side. Oops, no x here. So that will be x squared minus 2x minus 8 equals to 0. Oh, I think we saw this question earlier. Is it the same with the one above? Oh, yeah. Some kind of deja vu for me. So this will be x minus 4, x plus 2 equals to 0. But this one we need to be careful. So x1 equals to 4. Will that be okay? I think it's not okay here. It's not okay there, right? It's actually not okay here either, I believe. Yeah, but 1 minus 4 is negative. So I need to cancel that 4. Oh yeah, that's plus 2. Thank you. Thank you. So this should be plus 2, so it becomes plus 4, and this is minus 2 instead. So no, I may not cancel that one. So x minus 4 is okay. Yeah, that one is okay. Is right? Because if x equals to negative 4, this is 16 minus negative 24. So it becomes positive. Right? It becomes positive for that one. And this one, 1 minus negative 4 is also positive. So how about when x equals to 2? No, it's not good here. At least one of them not good, then we cancel it already. Okay, well, thank you, by the way. Thank you. This part B has the following notion. Some students think that the solution has to be positive. No, it's not that the solution has to be positive. It's about the argument. The argument has to be positive. So this has to be positive. This has to be positive. Okay, it's not about the solution being positive or not. No, no, no. This, like you can see here, the solution may be negative. Okay, and we still accept that because it makes the argument positive. So it's about the argument, it's not about the solution. Okay, now here we reject the negative part, not because we reject this one, not because it is negative answer, but it's because when I plug that into either one of these, I get negative argument, and that's why I reject that. Okay. It's not who you are, it's about what you do. Okay, it's not about that it is a negative number, but because what that negative number doing in the argument. Okay, it's not about who you are, but about what you do. Okay. Now let me go on to part D. I will distribute that log 2 and then isolate the x term on one side. Then factor the x. So x is equal to negative 2 log 3 minus log 2 over 4 log 2 minus log 3. This is the exact solution. Now then, let's see what will that be in approximate solution. Let me show you how I will type it again. You see that we have numerator denominator, right? So the first parenthesis will be for the numerator. Negative 2 log 3, close that log 3, minus log 2, close that log 2, and then close the numerator. Divided by, open the denominator, 4 log 2, close that log 2, minus log 3, close that log 3, and then close the denominator. Negative 1.72665. Okay, so did you get both of these?
Yes.
Okay, great. Thank you. How about you? The other one?
Yes.
Okay, good. Let's go on then. Let me know if you need to update though. Okay, or if you make mistake, then try to find out what kind of mistake you make. Number 2, let's see what is this about. That's the central angle and center with radius 5. We need to find the perimeter and area. That's 5.1. I think we will do that either Wednesday or, and I will see if we have enough time today. If we have enough time today, I will just go on with that 5.1 material. Okay, but let's do the logarithm first. Okay, express log base 2 of these as a sum or difference of simple logarithms. This is equal to log base 2 of 2 squared x to the power of 1/3 over y squared c to the power of 1/2. In one single step, this is 2 log base 2 of 2 plus 1/3 log base 2 of x minus 2 log base 2 of y minus 1/2 log base 2 of z. And 2 log base 2 of 2 is just 1, right? So this is 2 plus 1/3 log base 2 of x plus, minus 2 log base 2 of y minus 1/2 log base 2 of z. That's for number 3. Number 4. I make up questions myself here. Precalculum. We have a radioactive material with half-time of 1.5 years. Assume exponential decay. Now, this is a section that I didn't go over in my lecture, but a material follows exponential decay if it basically follows exponential form, which is the first, the initial amount. The amount after time t is equals to the initial amount times e to the kt, where because it's decay, the k will be negative. Okay, some textbook use negative kt on the exponent so that the k becomes positive. I will keep it negative. Okay, I will keep it. I will keep the k negative, so I don't use the positive for this coefficient of k. Now, what is the decay constant k for the material? The half-life time is 1.5 years. Means in 1.5 years, the amount of after 1.5 years is half of a sub 0, the initial amount. That's what it means. Okay, so a 1.5 equals to a sub 0 times e to the k times 1.5, right? But at the same time, we know 1.5 years is the half time, which means this is half of the original amount. Now that way we can cancel a sub 0. The initial amount equals to, so this is equals to e to the 1.5 k. Apply natural log. Right? It's basically changed into logarithmic form. So the k is natural log of 1/2 over 1.5. But natural log of 1/2 is negative natural log of 2. Okay, now this is the exact form. That's the exact form, and the approximate form will be negative 0.46210. Okay, now you may want to memorize this formula. half time k is given by negative natural log of 2 over the t. Okay, now negative natural log of 2 is because of natural log of 1/2. Right? Find the k such that in 1.5 years, the amount of that radioactive material only half left, half of the original amount. Like that. Okay? That's how we get that. That's actually the general formula. So this guy here is actually coming from this. And this is the time. In other words, if you happen to memorize the formula, you can just use this, which I did with that class. I think I did that with that class. I give them the formula. So some of them remember that, some of them don't. Now, find the amount of this radioactive material at the end of 2 years if the initial amount is 100 grams. Okay, so we want to find, so let's write down the formula first then. The amount of time t is the initial amount times e to the negative 0.46210 t. Okay, now then after 2 years, with the initial amount 100 grams, how much left? Okay, now let me use my calculator. I wonder if you know how to use your calculator. Let's share that with you first. Oops, I already have it. So I will do e to my e is here. That's my e. Now, if you ever use TI-30 or TI-36, find out where's your e. Okay, and then to the power of e to the power of negative 46210 times 2. Doom. Is it? Oh, I'm sorry. I forget the 0 point. So e to the negative 0.46210 times 2. Then multiply by 100. I get 39.68488. That's 39.68488 grams. Okay. That's for this number 4. Let's go on. Number 5 is something we have in our 5.1. Number 6, oh, this one again. Log base 2 of x plus 5 minus 3. What is the y-intercept? So f0 equals to log base 2 of 5 minus 3. Our y-intercept will be 0, log base 2 of 5 minus 3. Now then, let me approximate this using calculator. Log base 2 of 5, that's log 5 divided by log 2 minus 3. That's negative 0.67807. How about the x-intercept? 0 equals to log base 2 of x plus 5 minus 3. Move the 3. And then write it in exponential form. That's 8 minus 5 is 3. So the x-intercept will be 3, 0. The asymptote, x plus 5 is equals to 0. So the asymptote is x equals to negative 5. How about the domain? The argument has to be strictly positive. So x is greater than negative 5. So the domain will be from negative 5 to infinity, not including negative 5. How about the range? The range of exponential function is all real number. If the domain covers all positive number. Okay, now let's sketch the graph. Let me do the vertical asymptote first. Vertical asymptote, x equals to negative 5. The y-intercept is approximately negative 0 point something. So it's approximately here. X-intercept is 3, 0. That's a nice coordinate. Okay, but that's all we have right now. Then I need to do the important coordinates thingy. Right? Okay, now then the base is 2. Log base 2 of x has these 3 important coordinates. Actually, if you want, you can add this guy and then this guy, just to help out. But focus on these 3. Focus on these 3. Okay, now doing that, this guy move 5 units to the left and 3 units down. 5 to the left, 3 down. So it will end up here. This guy move 5 to the left and 3 units down. It will end up here. This guy 5 to the left and 3 units down. It will end up here. Okay, so the view will be, the view will be pretty much, we get this. Okay, but if you want to work on more coordinates, let's do it. So for example, this guy, 5 to the left, 3 units down, it will be here. 5 to the left, and then 3 down. 5 to the left, 3 down. Oh, that's our X-intercept. So let me just add this one more coordinates, and then we are good to go. So our log base 2 of x plus 5 minus 3 has this shape and coordinates. That's the graph approximately. Now the thing is, what if, Thomas, I don't have graphing paper? I strongly suggest, if you don't print the test out, I strongly suggest you to at least print some graphing paper or prepare some graphing paper to help out. If you really don't have graphing paper, you don't even print it, then you need to write down the coordinates. Okay, you need to write the coordinates for this, and for this also. Okay, you can't just give me, oh, this is my graph. This is my graph. No, because even if you use graphing paper, I want to see your important coordinates, right? So you need to give me what happened to those 3 important coordinates. Give me the coordinates. Okay, label it. Label it. Not just like without any further informations. Okay. Yeah, but if you have graphing paper, of course, then you can just plot it. The graph is actually pretty clear because you have the big bubble, right? So that's for number 6. Let's see if I have more questions. Oh, this one here, number 7. I'm about to give you a break. Number 7, it's good. Not these, not these. This one. So we will do number 7 and number 12. Yeah, my numbering gets screwed up though, because after this number 7, I see number 5 and then number 8. Okay, let's do this number 7 and then we take a break. What is the y-intercept? That's f0. That's 2 squared minus 3. That's 4 minus 3. That's 1. Y-intercept 0, 1. That's Mickey Mouse. About x-intercept, set the y equals to 0. 3 equals to 2 to the x plus 2. Now log base 2 of 3 equals to x plus 2. Negative 2 plus log base 2 of 3 equals to x. That's the x-intercept. -2 plus log base 2 of 3, 0. Now you can approximate that using calculator. Oops, let me use green color. Log 3 divided by log 2 because of change of base, and then minus 2. I get x is equal to negative 0.41504. Now that's the approximate. Notice that the formal solution for your x-intercept is in exact form. Now, what is the purpose you want us to do the approximate form, Thomas? Well, so that later on when you can plot it on your coordinate system. Okay, we can approximate that, right? So for example, the x-intercept later on will be negative 0.4 approximately here. Okay, your y-intercept is 0,1 is approximately here. Oh no, that's not approximate, that's the exact one. Okay, but 2 coordinates is definitely not enough for us to graph that exponential function. Okay, so we need to do more. How about the asymptote? The asymptote is y equals to 3. I'm sorry, y equals to negative 3. The domain, that's exponential function, though the domain is all real numbers. And the range of this function is from negative 3 to infinity. Because 2 to the x has range greater than 0, moving it 2 units to the left will not change the range. Subtracted by 3 will move the range down by 3 units. Okay, that's how we get that one. Now then, the asymptote is y equals to negative 3. Now, what happened to those important coordinates? Base 2. So it's 0, 1, 1, 2, and negative 1, 1/2. I need to move 2 to the left, and then 3 down becomes here. 2 to the left, and then 3 down. 2 to the left, and then 3. Hold on, this is exponential. So no. This one should be this one, 2 to the left and then 3 down, so it should be here. I almost referred to the wrong coordinate. Okay, so our exponential function, the graph will look like this. Of course, feel free to add more coordinates. For example, the next one should be 8. Now, little discussion. Notice that the coordinate that I use here was not part of your important coordinates. And it's also not part of your x-intercept, y-intercept. Okay, so do I have to put it there, Thomas? No, you don't have to. But if I were you, I will. Why? Because even though I don't give you extra point for that, but if you have little mistakes other place, okay, I will compensate that with using this little extra. You can call that extra points, but I cannot give you that extra point. But I can use that to compensate for any small mistake that you make in other place. Okay, but I need a reason to give you to ignore your little mistake, and that's usually by you giving me extra stuff that I didn't ask for. Okay, now that's for the graph and the details of this exponential function. The reason we still go back to exponential function in this case is because you see how we use logarithm when we try to graph this exponential function, right, for part B. And some students consider these extra points because we have done exponential function in the past, the graph of exponential function. Okay, now I'm about to give you some 10 minutes break, but let me ask you to think about the following question here, this number 7. This number 7. Okay, give you some hint. For part A, to find the domain of log, the argument has to be positive. So what you actually do is to solve this. But then you go back to the material for test 1, how to solve nonlinear inequality, in this case, rational inequality. Okay. Now, second, how about the range, Thomas? Now, we know that the range of log function, the range for log function is all real numbers except. Notice that the range of this logarithmic function here, the argument x minus 1 over 2x minus 3 cannot be 1/2. Do you see that? Right? That's the horizontal asymptote. Right? Okay. So if the range, if the argument cannot be 1/2, the graph will look like approximately like this. The x-intercept 1,0, y-intercept 0,1/3. Okay, vertical asymptote, x equals to 3 over 2. Horizontal asymptote, y equals to 1/2. So the graph actually looks like this, right? So the range of the range just for the argument is all real number except 1/2. So what will happen to if you apply log to that, then the range will be all real numbers except log base 3 of 1/2. Okay, and then part B is to find the inverse of that log. Now that's just apply. So you what happened is this: you can do part B first, and then you compare that to part C. You see what I mean? Okay. Now part A will take you approximately 3 minutes. Part B will approximately 3 minutes. Part C is just a consequence of part B. A total of, let's say, 7 or 8 minutes plus 10 minutes break. Let's come back at 11:20. Yeah, we come back at 11:20. At that time, you are done with this number 12. Okay, you can take your break first and then come back working on this, or you work on this first and then remember to take your break. Okay. Okay, let's start again. The domain x minus 1 over 2x minus 3 has to be strictly positive. So step 1, critical number, x equals to 1, x equals to 3/2. Second, the sign graph, x equals to 1, give us 0, x equals to 3/2, also give us undefined. The sign graph, this will be positive, negative, positive. So the domain is from negative infinity up to 1, but not including 1, union 3/2 to infinity. Okay, that's for the domain. Next, how about the inverse function? Let me copy the function first. That's y equals to log base 3 of x minus 1 over 2x minus 3. So step 1 is that. Step 2, I swap the x and the y. In step 3, I solve for y. I change it into exponential form first. Now, this seems to be like Thomas, I don't know how to go on from here. I give you the idea. Consider this as your x. In other words, in the past, we already solved for y from this situation here. We already solved for y. So y equals to something, 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 right? Okay, now later on, instead of having x, you have 3 to the x, right? So instead of x minus 2 over x plus 3, let's say, I don't know for sure, that will be 3 to the x instead. Okay. Now let's see. So instead of having y equals anything in terms of x, we will have actually y in terms of 3 to the x. So 3 to the x times 2y minus 3 equals to y minus 1, right? Okay, 2 times 3 to the xy minus 3 times 3 to the x equals to y minus 1. But big warning though, big warning. 2 times 3 to the x is not the same to 6 to the x. Why not? Because 6 to the x is actually 2 times 3 in parentheses to the x. Okay, that's if you have 2 to the x times 3 to the x. But if you only have 2 times 3 to the x, and you cannot multiply this. Why? Because exponent comes first, then multiplication. Do you remember that? Okay, so 2 times 3 to the x is not 6 to the x. No, it's not, unless you have parentheses around the 2 and 3. Okay, so do not change this. Do not change this becomes 6 to the x. No, 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 no. Now I will move the y to this side and then move that 3 times 3 to the x to the other side. That way I can factor the y. And here I can make it 3 to the x plus 1 minus 1. So y is equal to 3 to the x plus 1 minus 1 over 2 times 3 to the x minus 1. That's our inverse function. Okay. Now then, how about the range of the function? The range of fx is equal to the domain of the inverse function. Which is all real numbers except when 2 times 3 to the x minus 1 equals to 0. Right? Okay, now let's solve that one. 3 to the x equals to 1/2, maybe to be more precise, cannot be equals to 1/2. So x cannot be log base 3 of 1/2. That's x cannot be negative log base 3 of 2. Because this is 2 to the power of 1/2. Okay. Now then, from here we say this is all real number except negative log base 3 of 2. Wait, am I recording this? Yes, I am recording this. Okay. Now, By the way, with this said, I need to tell you that I plan to give you a quiz that is due this Sunday. There will be a quiz due this Sunday. Okay, and that quiz I think will be quite long, like considered like 3 quizzes put together. So you should start working on that at least maybe tomorrow. Okay, and the material basically from what we have done today. This is to prepare you for your tests. Test 3, which is around 2 weeks or 3 weeks from now. Okay, no, it's like 2.5 weeks from now. Okay, now that's for our spring 20. Let's move on to fall 20. Oh, did I write solution up there? No, let me write solution first. Okay, we have done most of this already. Now, fall 20 test 3. We have something new here, something slightly new. Notice that the bases are different. What the hell? What are you doing, Thomas? So yes, this is new, huh? But not really, really new though. All you need to think about is like, okay, you have log base 2, log base 4. What is the common base? Base 2, right? So you change this into base 2, log base 2 of x plus 3, that stays the same, minus log base 2 of x over log base 2 of 4. Right? Now log base 2 of 4 is 2. Multiply by 2 just to clear up the denominator. So I get 2 log base 2 of x plus 3 minus log base 2 of x equals to 4. Now change it into single log. This will be log of x plus 3 squared over x equals to 4. Okay, so x plus 3 squared over x in exponential form will be 2 to the 4, which is 16. Okay, now from there, then we solve further. This is x squared plus 6x plus 9 equals to 16x. So x squared minus 10x plus 9 equals to 0. So x minus 9, x minus 1 equals to 0. Either x equals to 9 or x equals to 1. And both of them okay. We just need to check if the argument is positive. Okay, that's all we need. You don't need to check if they're exactly equal. You know, you don't need to do a full check. That's for number 1. Okay, so the key is that you do the change of base and you change it to the common base. Now, of course, this technique will not work if this were base 3 and this is base 2. Now, in that case, then we need to do something else. Okay, but I think that's beyond the scope of this course here. Or at least I don't want to ask that kind of question in your test. It will take longer time, definitely. Okay, that's for part A. Let's see part B. Log base 4 blah equals to log base 4 blah. Oh, that's the same base, Mickey Mouse. So x squared plus 2x equals to 4 minus x by 1-to-1ness. Then set one side equals 0. And then this is factorable. So either x equals to -4 or x equals to 1. When x equals to -4, will that be okay? Let me do a visual check, but -4 squared plus 2 times -4, that will be 16 minus 8. 4 minus -4, that's 8. Oh, okay, so both for x equals to -4, this guy is okay, this guy is also okay. How about when x equals to 1? When x equals to 1, this is positive, and this is also positive. Oh, okay, both of them okay then. Hardly happen, right? Yeah, both of them okay. That question is easy. Part C, 2 to the x plus 2 minus 2 to the x equals to 96. I think I showed you this before somewhere, or maybe the other class. So I basically break the 2 to the x plus 2 into 2 squared times 2 to the x. And then you see we have common factor 2 to the x. Right? Now 2 squared minus 1, that's 3. Divided by 3, that's 32, which is 2 to the 5th. So x equals to 5. Now this one is a bit tricky. The trick is actually here. That's the tricky part. Now the fact that you have common factor 2 to the x, it's actually not tricky, but you need to get used to it. Okay, basically you see something blah minus something blah, then you have common factor blah. Then therefore you can factor it. Okay, that's for 1C. Let's see 1D. We have done this type of question a lot. And again, this type of question, part D, always in your tests. So get ready, get used to it. Okay, in the past we use log base 10. Let's use another log this time. Let's use log base 4. So this is log base 4 of 4 to the 2x minus 1 equals to log base 4 of 5 to the x minus 3. This becomes 2x minus 1 log base 4 of 4 equals to x minus 3 log base 4 of 5. But this guy is equal to 1, right? So 2x minus 1 equals to x minus 3 log base 4 of 5. Which actually, if you think about it, you can do it faster by seeing this as 4 to this power equals to this. And if you change that into log form, that will be log base 4 of 5 to the x minus 3 equals to 2x minus 1. And this will be the next step. Right? In other words, applying log base 4 both sides, okay, takes 3 steps compared to if you see this as exponential form with base 4 and you change that to log form base 4. Okay, now then the next step you bring x minus 3 to the front. That's what it looks like. Okay. So yes, you can do either way. The first one, you apply log base 4 to both sides, which is okay because log base 4 is a one-to-one function. right? But it takes 3 steps to get to our final form. While if you see that from log base, that's exponential with base 4 and change it into log form, it will take only 2 steps. Well, anyway, but we will get into eventually to get the same pattern here. Now then I will distribute log base 4 of 5 on the other side. And then collect the axis. Collect the axis on one side and constant on the other side. Factor the x. So x is equal to 1 minus 3 log base 4 of 5 over 2 minus log base 4 of 5. That is our exact form. How to get our approximate form? Then you will rewrite it first. X equals to 1 minus 3 times log base 5 over log 4 over 2 minus log 5 over log 4. Basically change of base, right? And then from there, you may want to multiply by log 4, both on the top and the bottom first, which will give us x equals log 4 minus 3 log 5 over 2 log 4 minus log 5. By the way, this is still exact form. It's just different base right now. If earlier you did it in base 10, if since the beginning you apply base 10, then that's what you will get. This is what you will get if you do base 10. Okay, that is still exact form. Now then from there, you do the approximate form, you use calculator to compute that. Now don't forget the interplay between parentheses. I don't show you anymore, but you try to do this on your own. When I use my calculator, I get x equals to negative 2.95922. This is the approximate form. Okay, that's for number 1. Number 2, we have log function again. What is the y-intercept? So f0 equals to log base 2 of 4 minus 3. Log base 2 of 4 is 2. So y-intercept 0, -1. How about the x-intercept? Set the fx equals to 0 and solve for x. So x is 4, right? Because 2 cubed is 8. So the x-intercept will be 4, 0. How about the asymptote? X plus 4 equals to 0. The asymptote will then be x equals to -4. How about the domain? X plus 4, the argument has to be strictly positive. So x has to be strictly greater than -4. How about the range? The range is all real numbers. if there's any exclusion on the range, it is the number you exclude because of the argument. Okay? Yeah, the number you exclude because of argument. Usually it's because of the horizontal asymptote if you have rational expression inside the argument. How about the graph? Let's see, the X-intercept is 4, 0, Y-intercept 0, 1. So 4, 0 is the X-intercept, 0, -1 is the Y-intercept, and then vertical asymptote is X equals to -4. What is the function again? See, log base 2 of X plus 4 minus 3. Let me copy that here so that I can see better. Okay, now let's talk about important coordinates of log base 2 of X. Log base 2 of X has these important coordinates. Okay, but I need to move 4 units to the left and 3 units down. So it becomes here. 4 to the left, 3 down, it becomes here. 4 to the left, 3 down, becomes here. So my new important coordinates are located here. Now let's put them together. This will be the graph. Okay, that's for number 2. Let's see number 3. Using sums and difference of a simpler logarithmic expression. This is log base a of a to the power of 6b to the power of 5 over c squared to the power of 1/3, right? Which is equal to, how fast do I want to do that? 6 over 3 log base a of a plus 5 over 3 log base a of b minus 2 over 3 log base a of c. The 6 over 2 is 2, log base a of a is 1, plus 5 over 3 log base a of b minus 2 over 3 log base a of c. Boom. Part B, natural log of this to the power of 3/2. Oh, I think this one is actually on the easy side. This is 3/2 natural log of e minus 1 minus 3/2 natural log of e plus 1. And that's it. Just one step. Compute the exact value without calculator. Oh, this one is good. The trick is call this x for now. And then you change it into exponential form. 27 cube root of 9 is 3 to the x. Now this is 3 cube for 27. 9 cube root of 9 is 9 to the power of 1/3. Right? But 9 to the power of 1/3 is 3 squared. So this is 3 cubed times 3 to the 2/3 equals to 3 to the x. 3 to the 3 plus 2/3 by 1 to 1ness. x is 3 2/3. Or you can call that 11/3. Okay, that's for number 4. Am I too fast? I hope not. Number 5, graph of cosine, that's later next week. Number 6, graph of sine, that's next week. Number 7, that's the material we'll go over tomorrow. Okay, number 8, we can use calculator to do that. Number 9, that one I think we need sometime next week. Okay, number 10. Now this question has something to do with what we did earlier, the last question of spring 20. Last question of spring 20. Remember we did this part? Okay, that's from spring 20. Now fall 20, basically a very similar situation. Part A, find the domain of this function, log blah. So the blah has to be positive. Okay, so critical numbers, x equals to 6/4, which is 3/2. And x equals to 2, that make it undefined. Sine graph, that's 3/2, that make it 0. 2, that make it undefined. Now we need the positive part. So the domain will be -infinity up to 3/2, but not including 3/2, union 2 to infinity. Part B, find the inverse. We have this routine before. Okay, so step 1, y equals to log base 3 of 4x minus 6 over x minus 2. Step 2, we swap the x and y. Step 3, change it into exponential form, and then solve for y from here. So this is 3 to the y times y, 3 to the x times y minus 2 equals to 4y minus 6. 3 to the xy minus 2 times 3 to the x equals to 4y minus 6. Collect the y's on one side. And the one without y on the other side. Factor the y. So the y is 2 times 3 to the x minus 6 over 3 to the x minus 4. Okay, therefore the inverse function, let me go here, inverse function will be 2 times 3 to the x. That's not 6 to the x. That's not 6 to the x. 3 to the x minus 4. Now, how about the range of the function? That is equals to the domain of the inverse function. And actually, we don't need the inverse function. You just need the inverse. Okay, you just need the inverse. Then from that inverse, you see it will be undefined if the denominator equals 0. Okay, so this is all real numbers except when 3 to the x minus 4 equals to 0. Now let's solve that. Okay, 3 to the x equals to 4, so x equals to log base 3 of 4. Okay, so that's all real number except log base 3 of 4. That's the range. How about the x-intercept of this function? Oh, we said the y equals to 0. Log base 3 of 4x minus 6 over x minus 2 is 0. But that is 3 to the 0, right? Which is 1. Which means x minus 2 equals to 4x minus 6. 4 equals to 3x. X is 4 over 3. So the x-intercept will be 4 over 3, 0. How about the horizontal asymptote? How about the horizontal asymptote? In the exact form. Now you see that we have horizontal asymptote here. Right? Okay. So horizontal asymptote for argument is y equals to 4. Now, if you apply the log, then horizontal asymptote for fx will be log base 3 of 4. Of course, I need to put the y in front of that. And it has something to do with the fact that the argument cannot be 4, such that the range cannot be log base 3 of 4 here. How about the vertical asymptote of fx? You will see there are actually two vertical asymptotes. There are two vertical asymptotes, not only one. The first one comes from the vertical asymptote for log. Okay, that is x minus 4x minus 6 over x minus 2 cannot be 0. That's when x equals to, when the argument equals to 0. But that's basically when x equals to 3/2. Now, the second one is vertical asymptote resulted from the argument. Notice that you have vertical asymptote here. X equals to 2. Okay, so they are two vertical asymptotes. And actually you can see that from sign graph. You see that from sign graph. Remember for log, we have vertical asymptote is if when the argument equals to 0, right? When argument equals to 0, and you have a positive side next to it. So that's one vertical asymptote there. Now, but you have another vertical asymptote here due to the argument which is in rational form. Okay? So that will be, I think that's the last problem for this fall 20. I do it a bit faster, to be honest with you, because I thought that I will be running out of time. But yeah, I'm actually 1 minute over time. Okay, but basically we finished the log part, the part from chapter, is it chapter 4 or chapter 5? Chapter 4. Yeah, we're done with chapter 4 material for test 3. The log form, logarithmic function, logarithmic and exponential equation. Okay, that's for today. See you then on... Oh, by the way, I just get the news that I will not be here on Wednesday. My appointment being approved for Wednesday, 8 o'clock in the morning. Okay, so 8 o'clock in the morning, but I need to go to Kaiser, which is on my way back here, I will get traffic. The thing is, like, I'm not sure what time I will be done there. So let me just cancel the class. Okay, I think the earliest I can come back here is actually 10 o'clock. That's the earliest I can guarantee. Maybe after that. So let me just cancel that class on this Wednesday. Okay, see you then on Monday next week. Oh, don't forget that we have you will have, I will post a quiz by maybe either this afternoon or tomorrow morning. Okay, bye-bye.